All right, let's talk about this question. What are the what are the treatments, not experimental units, what are the treatments? New drug or the placebo, yes. What are the experimental units? Yes. Close. She said 36 pairs of identical twins, and that is probably the most common, not completely correct answer that I've had. Not with acne. Nope. Juwan? 72 people are the 72 identical twins. They're not being treated as a unit and having the same treatment applied to both twins. So our experimental units are all 72 people involved. They're going to be matched, but every single person is going to receive a treatment. So when you're thinking about your experimental units, and I know we've struggled with this a little bit, and that's fine. It's a new concept, new terms, and we're not just calling them participants. We're calling them experimental units. Think about what is it that will be receiving the treatment. In this case, the twins as a group don't receive the treatment. They don't receive a single treatment. Each twin is going to receive their own treatment. Does that make sense? Okay. So that would be the 72 people that receive the new drug or the placebo. What is the response variable? Yes, improvement in acne severity, yes. No, that would be fine if you put on, if you said, on a scale from 0 to 100. But one of the things that I saw when I personally was grading students' work on this question was we would get acne severity as the response variable. That is not the response variable. The severity is not the response. It's how much did it change? What was the improvement? The final minus the initial. Similar to what we did with the Diet Coke. All right, on to part B. For the dermatologist experiment, describe a statistical advantage of using a matched pairs design where twins are paired rather than using a completely randomized design. What would be a benefit of using the twins in a matched pairs design versus completely randomized? So we have something that we could reliably compare to? Yes. So one of the things that we're looking for here, and I had quite a bit written because I looked at, I copied straight out of the responses that were put out by College Board for this question. So we're going to read through what they had, and then we'll talk about what are the essential components that you have to have for a full and complete answer here. Because improvement scores will vary due to many factors, including initial acne severity, what treatment is received, and other variables such as diet and genetics. So these are all kinds of things that are going to go into what affects people's acne. Because the pairs of twins are similar in initial acne severity, pairing allows for the variation in improvement scores due to the treatment received to be distinguished from variation due to initial acne severity, unlike in a completely randomized experiment. So it did say at the beginning that the pairs of twins had similar levels of acne as each other. So being able to pair them together, one of the other benefits here is not only do they have the same starting level of acne severity, what else do they have in common? They have their genetics in common. And while not 100%, what else do they also likely have, not exactly the same, but in common? Hormones. What else? Do you think they probably eat in a similar way. They probably eat similar types of foods as their twin. Probably not exactly the same, but very similar. Like you're not going to have somebody that only eats carbohydrates and another twin that probably only eats protein. They're going to eat what's available at their house and the way it was prepared at their house, right? So things that you had to have on this part of the question for it to be considered a fully complete answer. You had to describe a statistical advantage and hit these 3 points. The advantage pertains to an inference made after collecting the data. So we have to talk somewhere in there about the improvement in the scores. Somewhere talking about what it is that we're going to compare. You need to indicate that the matched pairs design is better by using comparative words like easier, greater, clearer. Somewhere in there you need better. And you need context. So places where this were hit, it talks about the initial acne severity and looking at the improvement in scores due to the treatment received. That's talking about what we're looking at the end of the experiment. When you talk about the ways that the twins are similar, you're talking about why you would want to pair them together because of their similarities, but you're not saying why that would be an advantage in the end. And what we want to see is why would that be advantageous at the end of the experiment. So right here, using a matched pairs design will provide a more precise estimate of the mean difference in improvement in acne severity for the new drug compared to the placebo and make it easier to find convincing evidence that the new drug is better if it really is better. If you just had some variation of this very last piece, that hits all of the important parts. It talks about what we're comparing at the end, the improvement in acne severity, talks about why this matched pairs design would be better than a completely randomized design using, where was it? I think it says better. More precise estimate, and makes it easier to find. So you want that language that we use, like similar to when we talked about distributions and we were comparing to, you want to use those comparative words there. You want to make sure that you have context. All right, on the back side, for part C, describe how the treatments can be randomly assigned to people using a matched pairs design in which twins are paired. So what is the first thing that you would want to do? Line them up, okay? What do we do once we've got them lined up? What'd you say? Find the person with the most acne and pair them with their twin, right? Okay, so we want to put all of our groups of twins together. Once we have all of our pairs of twins made, what do we want to do now? Yes. Assign them an A and a B in each pair of twins. Let one twin be twin A, let the other twin be twin B. Or you could assign them numbers 1 and 2. What would we do with them once we label the twins in each pair? Yes? We could absolutely do that. Flip a coin. If it lands on heads, twin A gets the placebo, twin B gets the new drug. If I fully stop right there, that would not be considered a complete answer. I got to take one more step. If it lands on tails, yes, then twin A gets the real drug and twin B gets the placebo. There's one other thing that I have to say at the end that we haven't mentioned yet. You could do it like that. But there's one other piece that I'm looking for, because right now, with the way we've described it, we only have 2 people getting treatments. Repeat this for all pairs of twins. Label one person twin A, the other twin B, flip a coin. If you say right here at the beginning for each pair and then you describe the method, you wouldn't need to mention that again at the end, but somewhere in your response, you have to mention that you're doing this for each pair of twins. It can be at the beginning, it can be at the end, it just has to be somewhere in that answer. How did this one feel compared to yesterday? Did you guys feel a little bit more comfortable with this question? A little bit. This one was a tricky one, especially on that experimental units part. A lot. I would say when I graded this, probably 75% or more of students put pairs of twins as the experimental units. I do want to really stress going into not just the AP exam all the way in May, but coming up on Friday, experimental units are the things that are receiving the treatments. The things that receive the treatments. So if I were to apply treatments to, say, different classrooms here at Pike, if I wanted to find out if different scents improved student scores, then my classrooms would be my experimental units because that's what I'm applying the treatment to. The students would be inside the classrooms, but the students wouldn't be my experimental units because they are not being assigned a treatment. The classroom is being assigned a treatment. Does that make sense? Okay. I want to open it up for the next about 20, 25 minutes and take any questions you guys have off the review, since I don't get to see you tomorrow. And then I want to end class, hopefully, with another FRQ. Just another opportunity to try one of those free response questions. More of the packets? The reviews, yes, very bottom paper. Absolutely. Number 7, a researcher observes that on average, the number of divorces in cities with Major League Baseball teams is larger than in cities without Major League Baseball teams. Which of the following is the most plausible explanation for this observed association? All right, so let's just think about the implication that was made here. If the city has a Major League Baseball team, they have more divorces than cities that don't have Major League Baseball teams. What do you think would be an important thing to recognize before we even look through these answer choices? Does Indianapolis have a Major League Baseball team? Does Los Angeles? Los Angeles does. What's the difference between Indianapolis and Los Angeles other than one's in Indiana, one's in California? Population. Los Angeles is a lot bigger. Would you expect there to be more divorces in Los Angeles than Indianapolis? Just based on a sheer numbers game. There's a lot more people in LA than there are here. All right, so choice A, the presence of a Major League Baseball team causes the number of divorces to rise. Perhaps husbands are spending too much time at the ballpark. Have they indicated anything here that would allow me to say cause? No. What would we have to have if we're going to talk about cause? We need a randomized experiment. Choice B, the high number of divorces is responsible for. This is just another way of saying what? Cause. The higher number of divorces is responsible for the presence of Major League Baseball teams. More single men means potentially more fans at the ballpark, making it attractive for an owner to relocate to such cities. What do we think? I don't think that's one of the things that gets looked at. Also, we don't have cause here. The association is due to confounding. Major league teams tend to be in large cities with more people, hence the greater number of divorces. How do we feel about that one? I like that one. I haven't read all my answer choices yet, so I'm going to star it because I like this one. But if there's a better answer further on, then I'm going to put that one. The association makes no sense since married couples go to the ballpark together. It might be true, it might not be true. It does not have any bearing on this particular question. The association is purely coincidental It is implausible to believe the observed association could be anything other than accidental. No, we already gave one possible reason for why we might be seeing this association. So I would go with answer choice C. All right, what else would you guys like to see? Yes? 15B, absolutely. All right. It says bias is present in each of the following sample designs. In each case, identify the type of bias involved and state whether you think the sample proportion obtained is higher or lower than the true population proportion. So in part B, it says in 2003, the AARP conducted a survey of their members, people over age 50 who pay membership dues, on proposed Medicare legislation. One of the questions was, even if this plan won't affect you personally either way, do you think it should be passed so that people with low incomes or people with high drug costs can be helped? 75% of the respondents answered yes. What do we think? There's two that come to my mind, and I could go with either one of them, depending on the reasoning behind it. I could call this response bias. Why? It's almost like they're guilting people into saying, yes, if somebody's low income, don't you want them to be able to access their medication? If somebody has really high drug costs, why would you stand in the way of that? Almost feels like that question is asking this. Would this over or underestimate? This would overestimate. There's another kind of bias that I could go with on this one. Yes. I would put under coverage too. Who is likely to be affected by this legislation? Yeah. Anybody that's on Medicare or getting ready to go on Medicare. Medicare is the government insurance that is for people who are elderly, 65 and older. Maybe they moved it to 67, 60 something and older is Medicare. Who did AARP ask? They asked anybody that's over 50 who pay membership dues. If you have money to be paying membership dues, are you really pinched for cash on your drug costs? No. If you can't afford membership dues, would you maybe be more likely to say yes to this one because you can't afford other things due to your medication costs? So I think if you look at this like under coverage, we might be getting an underestimate here. I think the type of bias here kind of really depends on whose opinions is the AARP actually interested in. Are they only interested in their members' opinions? If that's the case, then I would go with this being response bias. They asked just their members. If that's the population of interest for them, then that wouldn't be under coverage. But if they're interested in anybody that this legislation could affect, they did not go to that pool of people. They only asked their members, so then we'd be looking at under coverage. But I could be argued either way on this one. Yes? Sometimes there's more than one type of bias that you could identify. Yeah, I would say if this was worded slightly differently, it might have narrowed the field down. If it had said something like one of the questions was, do you support legislation that would help low-income people with their drug costs or would help people with high medication costs? And just kind of leave it at that. Or, you know, the proposed legislation says X, are you in support of it? And just kind of let that language stand on its own. Then I probably wouldn't go with response bias. But with the way this question is answered, or the way this question is asked, I think definitely influences the answers. So yes, I do think that it's possible to give more than one type of bias.
Are you supposed to give more than one, or is it okay if we just choose one?
I would say if the question starts like this one where it says identify the type of bias involved, as long as you identify one, that would be sufficient on a question like this. Yes, Erin? Oh, awesome. What other questions would you guys like me to go over? Yes?
It was 16C and 16D.
16C and D? All right. Read the following article about the connection between vitamin E and heart bypass surgery. Vitamin E may have special health benefits. Large doses of vitamin E apparently can reduce harmful side effects of bypass surgery in heart patients. A study involving 28 bypass patients found that 14 randomly assigned patients who took vitamin E for 2 weeks before their operations had significantly better heart function after the procedure than the 14 randomly assigned patients who took placebos. I see some things that I'd be circling up right now if this was on a test. Does anybody see any words that they'd be circling? Randomly assigned. I would want to circle that because that's going to be important as we're answering questions about this. The vitamins apparently prevent damage to the heart muscle by destroying the toxic chemicals called free radicals that form when blood is cut off during the surgery, said Dr. Terence Yao of the University of Toronto. Identify the type of experiment design used in this study. Justify your answer is part C. What's the only thing they told us about the design? People were randomly assigned. Were they split into groups before they were randomly assigned? Were they matched up with other similar patients before they were assigned? So then this would be a completely randomized design. To the best of our knowledge, this is a completely randomized design. Each subject or patient was randomly assigned to one of the two treatment groups. And then part D, in the second sentence above is the phrase 14 patients who took vitamin E for 2 weeks before their operations had significantly better heart function after the procedure. Can the results of this study be generalized to a larger population, and can cause and effect be inferred? Let's deal with the first part of the question. Can the results be generalized to the larger population? What do you have to have if we're going to generalize to the larger population? Random sample. So I'm going to ask myself, was there a random sample? Did we have a random sample? No. So no, we cannot generalize to the larger population. Because there was no random sample. This is why I write with lines typically. All right, what about the cause and effect question? Can we determine cause and effect? Yes. Why? Because we have random assignment. So yes, we can conclude that vitamin E caused better heart function for these patients because we had random assignment. Barely there. Assignment, it ran off the page. All right, what else would you guys like to see? Yes.
For 17E, do you have like the page number that we did on the ethics stuff?
Do I know the page number for the ethics stuff? Let me see if I can find it real quick. I know a general section. Data ethics starts on page 306, and it looks like it concludes on page 307. So pages 306 to 307. Seat number 6. You're welcome. So yeah, if you have not read up on the data ethics stuff, it's not a horribly long section in the book, but I would go through and read that. Anything else you guys want to see? Yes?
Whenever you talk about the experimental design for a study, if I said a block study, do I have to say a randomized block study to get the points, or if I just say a block study, it would count?
Ooh, let me think about that one for a minute. And just to clarify, I would say a design, not necessarily study, because it's an experiment, which is a type of study, but I would want to be a little bit more clear on that one, that I'm talking about an experiment here.
Okay. Now I'm talking about 17E.
17B.
Yeah, because you said
Is what I had. I'm going to have to check with somebody above me that's been doing College Board stuff long enough, or longer than I have. My gut reaction, me personally, not me that's graded AP exams, says if you called this a block design, would that be sufficient? I would say yes. I can verify with people that have graded these tests for as long as I've been teaching about whether or not you would have to say randomized block design, or whether block design alone would be good enough. Again, my gut reaction is that block design would be fine. So if you do that on the test on Friday before I've had a chance to get an answer back, I'm not going to take off points for that.
Okay.
It's like if you called it a matched pairs design or a block design, that would be fine. Yes.
Wait, for match pairs, you also have to say
I believe that one's just called matched pairs design. You randomize within the pairs. But I think because you do that matching at the beginning, they don't use that in the official title of it.
Okay.
You're welcome. Anything else you guys want to see? All right. That does mean that we have time for that last FRQ. Awesome, awesome. Okay, so what we're going to do this time, do not put your name on it. I am going to give you a number. While you're answering the question, I'm going to give you a number, and we're going to trade and grade. I will collect them so nobody knows who has who else's paper, but you will need to remember what your number is so you can get your paper back at the end. All right? A score of I would be an incorrect. Would be incorrect. All right. I think we go this way. No, go this way. All right. For the first part, keeping daily journals could introduce response bias. Again, this is the model solution. Could introduce response bias due to the self-reporting by subjects who may have a poor or incomplete memory of the amount of walking that was done. If most subjects who keep daily journals underreport the number of miles walked per day because they cannot remember all of their walking at the end of the day, then the estimate of mean daily miles walked for the target population will be biased too low. Wearing activity trackers would likely provide a more accurate record of daily miles walked by each subject in the study. You needed to hit on two things to get an essentially correct, which would be an E. You need to indicate that keeping a daily journal could result in a bias that would be avoided by using activity trackers. So we could have bias that could be avoided if there were activity trackers. And the second thing that needs to be hit on is one of these two pieces. Either use of a daily journal may result in a systematic underreporting or systematic consistent over-reporting of daily miles walked. So you had to indicate that this is going to be biased in one direction or another, or it could be biased in one direction or another. Or you could say the use of a daily journal may result in biased estimation, underestimation, or overestimation of a population parameter, the mean daily miles walked. So you need to talk about there is a bias that would be prevented by using the activity tracker, and then you have to talk about how this particular bias either would lead to overestimation or underestimation of daily miles walked for the population. If they hit both of those points, that would be an E. If you got one of those two parts, or if they got one of those two parts, that would be a P. And if they got neither of the parts, that would be an I. Flipping it over to the back side. Selecting a random sample creates a reasonable representative sample of the target population. Explain the benefit of using a representative sample. It's necessary to have a representative sample of subjects from the population in order to make an unbiased inference about the difference between the mean cholesterol levels for all adult members of the target population who walk fewer miles per day and the mean cholesterol levels for all adult members of the target population who walk more miles per day. You needed to hit two components in order to get full credit. Provides an explanation that the use of a representative sample is necessary in order to make a valid generalization to the target population. And they need to refer to estimation or inference for cholesterol levels in the target population or an association between cholesterol level and amount of walking. So they needed to talk about generalizing to the larger population, and then they needed to talk about either an estimate or inference for the target population or looking for an association between cholesterol and amount of walking. If they hit both of those key pieces, they get an E. If they hit one of those two pieces, they get a P. Neither of them would be an I. And then the last part of this question, which apparently my board doesn't want to work now. Can we determine cause? No. Since the treatments were not randomly assigned, it would not be valid to claim that increased walking causes a decrease in average cholesterol levels for adults in the target population. They would only be able to conclude that there is an association. There may be one or more confounding variables. That came faster than I thought. So they need to say, no, you cannot determine cause and provide a valid explanation. Either there's no random assignment, or it's an observational study, or there could be confounding variables. If they hit both of those pieces, it's an E, only one is a P, none is an I. Please come and place the papers up on these desks and then grab your own. Place the paper up on the desk and grab your own. I have number 4, number 19, your number 4, number 9, number 12, number 13, number 1, that's yours, number 16, number 11, number 10, number 5, number 18, 7, which number are you here? 3. Got 6, 17, 15. Does anybody have number 3? You're 15? 3. You're welcome. Right, please come find the paper. Awesome. Nice work, guys.